So the guy from church can see it.
Okay, I'll put it on public so everybody can access it. All right?
That's gonna see
No, he doesn't. Well, if he does, he doesn't go to church anymore, so he won't talk to me.
it. He's gonna comment.
All right. Calc. Just leave it there in case someone else comes in. Calc.
Like everything.
Okay. Rana, Tatiana, Helena. What would you like me to do?
All of that.
Is Rana ready?
They don't say that.
Shh. Are you on the exam review, Rana? Okay. Page 19. All right. So this is page 19, number 35. Okay? So I'm going to read, and as I read, we're going to talk about what's important, because you're going to be color coding next semester. It says F is differentiable. So this is a word that we would have color coded. What does differentiable mean? Has a derivative, and what else? Continuous. Okay. So if you don't think about that, you miss that. Okay? And then it continues and it says, and increasing. That's another important word. What does that mean if the function's increasing? Helena, Tatiana, the function's increasing. What does that tell us? What's positive? It. Define it. If the function's increasing, what's positive? Which one? Correct. F prime of x is greater than 0. All right. Then it says on the interval 0 to b. Okay. So this is BOLO. Be on the lookout. We should be on the lookout for EVT, IVT, MVT. Okay? But this is an interval, which means these are x's. That's important to know. And then now they're going to tell us that C is the number guaranteed by mean value theorem. Okay? So what is important about this is if it's guaranteed by the mean value theorem, that means that C is not necessarily a critical number. Okay? It's not necessarily a critical number. It's the C of the mean value theorem. Now, since they brought this up, what does that mean? Slope of what? Tangent equals slope of secant. Okay, these are all things that we're bringing out to our front of our thinking. Okay, so now it says which statement must be true. So that's all about the beginning, all right? So gentlemen, we're on page 19, number 35, in case you were interested. Okay, so now we're going to start looking at what they've given us, all right? This first one says that f double prime of c is less than 0. What does that mean, second derivative less than 0? Concave down. All right. Is there anything in this up here that leads itself to concavity? No. So that's great statement, but there's no validity in it. All right. So now look at B. B says that f prime of c is equal to f of b over b, I think. All right. So I'm looking at this and I see tangent slope. You with me? So I'm thinking, maybe this is the mean value theorem because we're at C. So let's look at what would the slope of the secant line would have looked like. We would have said f of b minus f of 0 over b minus 0. Okay? Now, b minus 0 definitely is b. My question to you is, just because it's f of 0, does that mean that y will always be 0? No. That could be any number. So they do not have minus f of 0. So this can't be the mean value theorem because they're missing this. Does that make sense? Okay. So now we're going to go to part C. Part C says that f prime of C is equal to 0. They're saying the derivative equals 0. Well, can the derivative equal 0 if they told us this? No. So that can't be true. So now let's go to D. And this time D says f prime of C is greater than 0. So what does first derivative greater than 0 mean? Increasing. And if it's always increasing, then it means it's going to be increasing at C also. Okay, but let's look at the last one. The last one says f prime of x changes signs at x equal c. Okay, now if that derivative changes signs, what does that mean? Correct. That means you either went from increasing to decreasing or decreasing to increasing. Regardless, at some point it's decreasing, and that goes against what they told us. Methods, it's your turn.
Can you do the stuff that looks like this?
What is it, normal or binomial?
I don't know. So what's that look like that? And then
Well, okay, so we're going to do one. So
there's like, I don't know if that's the one.
this is normal.
Something like this, I don't know how.
This is normal.
Okay.
Okay, so depending on which one you have will depend. So this is, first of all, they should have told you that x is a normal distribution. I don't know. I don't know.
Can you look at this?
You have to ask Faith.
I don't even know. One of your test objectives is I don't know any of this stuff. I don't know.
Which one do you question?
I have a test.
I can't read them from here.
Given a normal distribution and information about it, find the value of the mean. Is that
Oh, look, she wrote it. Oh. Which one don't you understand?
The circled ones.
You don't understand any of those?
That's not mine. Oh, I'm saying no. This one. It says, given the probability, find the x that gives the probability. What does that mean?
Where?
It doesn't make sense.
Where is it?
Given the probability, find the x that gives the probability.
Find the probability of a normally distributed data.
Yeah, you said
Now-
those are two separate questions.
Given the probability, find the x that gives that probability.
Yeah, I don't know what that means.
Okay, so did you turn the page so I can't do a problem now?
No, I'm looking at there's like, just anything that looks like this, I don't know what to do. Or like the ones that look like that. It's when you do the normal,
The pages just fell out.
I don't get this like that.
So at this point, I'm looking at 15H. We're looking at number 5. So 15H number 5, they said that Z is normally distributed with the mean of 0 and a standard deviation of 1. You with me? So now they want the probability that Z on 5 is less than 0.65. Okay? So, first of all, if you have a normal distribution, we want Z to be less than 0.65. And that would mean that if this is the mean of 0, do you agree 0.65 is going to be above? So that means what we're doing is we're looking for this area. Correct? So that means that you're going to do normal CDF, negative 9E99, that's negative infinity, to 0.6501. If you're looking, this is number 5 again. if you're looking for the probability that z is greater than 0.72. So now we're here. And again, your mean is 0. So 0.72 must be up here because it's positive. So we're looking for this. So now you're going to do normal, CDF. That's going to be, no, so you're going to do 0.72 is the low. Now we're going to do 9e to the 99, comma 0, comma 1. So now we're going to do, I don't know. She just wanted me to do this problem. So now we're going to do, what if we wanted the probability that z is between 0.1, negative 1, and 0.2? What would that look like? Negative 0.1 is going to be on this side. 0.2 is going to be on this side. Now we're looking for that area. So that's going to be normal CDF. And that's going to be negative 0.1, comma 0.2, comma 0, comma 1. So it's their turn. And then I'll come back. Pardon? That's a calculator. I don't have a calculator. You know, you need to do your calculator. I didn't say I would do one objective. I said I'd do one question at a time. Did you want your book? All right. Calc, which one are we going to go to next? Tatiana? On what page? Page 41, number 8. Okay. Look. So this is calc. This is page 41, number 8. Okay. So as I go through, I'm going to talk about what I would have highlighted. Okay. So it says we have a function, y equals x to the 4th plus bx squared plus 8x plus 1. And they're telling us that we have a horizontal tangent line. What do you know about a horizontal line? Okay. We've got a horizontal line. Okay. So we've got a horizontal line. It's a tangent line. So what do we know about it? What about the derivative? Derivative is the slope of the tangent line. So talk to me. Slope? The slope is 0. How do we get slope of a tangent line? Derivative. So what does that mean the derivative must be? Okay, that's important. But then it goes on and it talks about a point of inflection. How do we get points of inflection? Second derivative. And how do we do that? Second derivative equal to or undefined, correct? Okay, so they want, and what they're saying is wherever this occurs also. So now we want what must the value of b be? So let's start here. What do I need to do first? What am I supposed to do first? What does it say? Okay, so we're going to say y prime is equal to 4x cubed. Now b is a number, so that's going to be 2bx plus 8. And what am I supposed to do to this? So 0 equals 4x cubed plus 2bx plus 8. Okay. So now what does this tell us to do? You see we have two unknowns. That's a problem. What? Take the and. Thank you. So we're going to take the second derivative, which is going to be y double prime. And that's going to equal 12x squared plus 2b. Thank you. Oh, you got it today? You're so good. All right. Now what should happen here? So 0 equals 12x squared plus 2b. So now, we've got two equations with two unknowns. What if we solve for b? Can we do that? Or, I think we need to do that. So we're going to say negative 12x squared is equal to 2b. Bless you, what is b? Now, where are we going to put this negative 6x squared? Right there. So, different color. We're going to say 0 equals 4x cubed plus 2 times negative 6x squared times x plus 8. So you're going to say 0 equals 4x cubed minus 12x squared cubed. X squared times x is x cubed. And then that's going to be plus 8. And what's 4x cubed minus 12x cubed? How much? Negative 8x cubed plus 8. So we're going to add 8x cubed. We're going to divide by 8. So what is x? 1. Is that what they asked us for? Oh, see, we get so excited and notice they had that. They want the value of b. So now we're going to come over here and say negative 6 times 1 squared. B is negative 6. Methods. Let me finish answering the question that you started. We're going to alternate. It's only fair. Okay. So she wants to know the second part of that. What's it called? Objective. Given the probability, find the x. It's the second half.
That's what we just did, right?
No. We weren't given the probability. We were given the x.
Oh, is that the inverse?
Yes. So now we're going to go to,
This one?
yes.
Yeah,
So let me go to a new page. We're on 15K, and we're going to look at 2. I'm going to do 1B to start. So what about the probability that Z is greater than A? And that is going to be 0.342. Now, the fact that they use Z means the mean is 0 and the standard deviation is 1. That's special Z's. Okay. So if we look at this, draw yourself a picture. What we're doing is there is this Z-score, and we want to be greater than that. Inverse norm is always from the left. Okay? So if this area is 0.342, how do I get this area over here? 1 minus, it's right, 1b. 1 minus 0.342, which is what? Somebody better have a calculator because I'm wasting time. So that's going to be 0.658. Do you all agree? Did anybody do it? Double check his math? Okay. So that means that the probability that Z is less than A is going to be 0.658. So now we're going to inverse norm. As soon as you inverse norm, the probability piece, Z and inequality goes away, and we're going to inverse norm, where we've got 0.658, comma 0, comma 1. If by chance you had something like 2b, where they said they want the probability of A to be less than Z, but less than A, but less than 1.6, and that's 0.787. So now, and I can't even stress how important it is that you draw these pictures. Okay? So you know you've got an A here, you know you've got a 1.6 here, and you know that this is 0.787. Correct? We're finding A.
We have the inverse norm from A.
But that's the middle, that's not the end. Oh, so what we're going to do is since we have this, if I do norm CDF from negative infinity to 1.6, and it's a z again, to 0 to 1, that's going to give me the area from here all the way through. So I need that. Someone's got to tell me what this is.
Attention, Daniel O'Connell to the front office. Daniel O'Connell to the front office, please.
Okay, I'm assuming you're right, so I'm just going to go with it. All of this is 0.945. So how can I get just this piece right here? Because to get A, I need just that piece. So we're going to subtract 0.787, and what do we get? Okay, so now the probability that Z is less than A is going to be 0.158. It's from the left, now we can do it. So we're going to inverse norm, so we're going to A equals inverse norm of 0.158, comma 0, comma 1. And that's going to be your answer. AP, what's next? AP? Always from the left. Yes. 31? 41.7. 41.7. All right, this is page 41, number 7. They're back to AP. Oh. All right. All right, calc. What is, you've seen this before. So if we were, what's it called, color coding, what is this asking for? It's, okay, this is definition of derivative. Which one? Number 1. Okay, so what they're saying is they're saying take the derivative. Oh, I didn't spell that well. Take the derivative of. What's our function? The absolute value of x, and they're telling us at x equals 3. Okay, remember that worksheet I gave you 20 questions and I gave you the definition of derivative 4 ways? So this is the f of x plus h. So we take this and we replace it with x. That is my function. This is my y value. Okay? Now, this takes us back to the first week of school. I can't do this derivative unless I turn this to a piecewise function. To turn this to a piecewise function, I'm going to have the function, then the opposite of the function. I take what's inside the absolute value bar, set it equal to 0. That's how I get my where the vertex or that turning point happens. Which side of 0 keeps x positive, the left or the right? The right. Which side keeps this positive, the left or the right? The left. It doesn't matter where the equals is. So now, how this says take the derivative. How do we do the derivative of h? It's going to be 1 for x is greater than and equal to 0. It's going to be negative 1 for x is less than 0. Now, we want to do this at 3. So is 3 bigger than 0 or is 3 less than 0? So that means this is my derivative. So h prime of 3 is 1.
I'm still in the middle of my SNHS meeting, and it's probably going to turn into a board meeting after, so I won't be able to stay after school today. I start with school Thursday.
Uh-huh. Is this for exam?
No, it's for SNHS. Oh, wait, no, for, you want after school? Party choice. Or are we just going to...
Oh, yeah. No.
Okay, I got you.
Molly, you need me?
Yeah, I have some questions.
I can answer any questions on what I've written. Okay, so let me answer one of your questions, and then I'm going to go back to, are you ready? Yeah, you know where it is? It's in the drawer. Okay, I appreciate that. Look at the printer. Yeah, that's the only place I have it. Okay.
Here, how much am I supposed to, like, what do you mean by that?
You may
like,
want to write function in its rounded form.
And tell the reader this. So, like, do I be like, I'm rounding these values to the...
This is what you're
hundreds?
using. I don't know. Were you consistent in your rounding or not?
I don't know.
You foiled. You rounded a lot.
I stored it in the calculator and like did.
But when you multiplied, you got a whole lot longer number than this. Correct? Yeah. So...
And I just did it to 4 decimal places.
So you need to let them know that.
Okay.
That all your calculations are being rounded to 4 decimal places, because if I do it and not round, I get a totally different answer.
Okay, and you said your numbers were different. Do you know if they were like wildly different or just because of rounding?
Different. Which?
No, next page. It says like my numbers were different.
My
like,
numbers
do you know
were
if
different.
it was like wildly different or just like only a rounding thing?
No, I think it's more than rounding.
You think it's more than rounding?
I think it's more than rounding, yes.
Okay,
yes.
What else is there?
Did you solve this?
So that was just like the wrong thing, like it needs to be this instead of that, right?
I don't know. You're saying solving. Did you solve this?
Like this is like a header for like what I'm about to do.
Okay, is that a correct verb?
Solve. Okay, so change the
solve is an equation. Is that an equation?
No.
No.
Yes. I like solve.
Where's the equal sign?
Oh, okay. So what should I say instead?
What do you think it's? Look into calculate. See what they.
Calculating.
That's possible. Did you solve this?
Okay. What is function notation?
Did you use function notation? My numbers differ.
I don't understand
check your
function notation.
Well, okay. So look at your notation.
Here.
Yes.
Here.
Does it match? Did something change? Looking at the function piece.
This? Like the here?
Are those equal to? Are they the same or are they different?
Well, they're different. Yeah.
Right.
Okay.
My numbers differ. Since my numbers are above are different.
And then,
my answer is different.
Here. Okay, so bibliography and research cited. Do I have to have 2 different things? Like one is a bibliography and one is a research cited?
Well, if you have a bibliography, don't you have a bibliography because of research?
Well, I'm asking if they're 2 different things. Are they the same thing?
Well, if you attach a bibliography and you never reference it, what good is a bibliography?
Okay, but am I supposed to have a bibliography?
Well, it is a research paper.
Oh, okay. So, okay. And then what else is on the back of the questions?
Yes, you have to have works cited. What's the difference? I don't know.
Oh, I just thought they might be like 2
Same
different
thing.
things that I needed. Okay.
Okay.
So I think that's everything.
All right.
Thank you.
So I think it's methods. Did she leave me? Did she think it was useless? What does it say? Like this? Or did they just tell you that? Is that true, 0.2, or is it? So it was 0.2. And you know that that's squared. Okay.
And then the p with the x is greater than a equals
0.235. Did you draw yourself a picture? I can't draw these. I can't do these unless I draw myself a picture. Okay? Your mean is 5.5. Correct? So you want x to be greater than a. So I don't know where this area is. So let's say this is a at this moment. They're saying that all of this area here is going to be 0.235. Can you do, so they've given you the area. You see it? That's the inverse norm. Can I do it from the right? So that means, how do I get this area over here? So you've got to do 1 minus 0.235, and I don't know what that is. Okay, so we are now going to say that the probability that x is less than a is going to be 0.765. Now what do? Inverse norm. So in other words, a is going to equal inverse norm of 0.765, 5.5, 0.2.
So the only thing that's different now, this one from the last one, is that it
A non-standard, right. But in the syntax, it's area, mean, standard deviation.
yeah.
Does it say area?
They will not say area. You have to understand the concept. That's why I draw the picture. They're giving you the probability. They're not going to say area. You have to understand that the probability is the area under the curve. AP? You know what? I think ultimately in a big fat stat book, in a really high stat class, it is an integral. All I remember is I took the stat class and I got stuck, and it's because it was some kind of calculus thing that simplified to 1. Ooh, that's a different one. Okay. Okay. So we've got page 80, number 12. Let's see what it says. It says the equation of the tangent line to the curve. All right, this is a curve. And the curve is y equals kx plus 8 over k plus x. And the equation line tangent to the curve y equals, this is occurring at x equal negative 2, is y equals x plus 4. Okay? This is the tan equation. So you've got this curve, you've got this line. This is occurring at x equal negative 2. This line is y equals x plus 4, and this is kx plus 8 over k plus x. Okay? So it says, what is the value of k? So what do you know about the y value on this line and the y value on that curve?
How long are you going to be here?
They're the same till about 2:45. They're the same. So can I say that kx plus 8 over k plus x is equal to x plus 4? And do we at least know part of this? Where's this happening? So can I say negative 2k plus 8 over k minus 2 is equal to negative 2 plus 4? So we get negative 2 plus 8 over k minus 2 is equal to 2. When we cross multiply, we have negative 2k plus 8 is equal to 2k minus 4. Subtracting 2k, I get negative 4k. Subtracting 8, I get negative 12. I think k is 3. Is that what it said? I had got D. True or false? That's a sweet one. So Faith has been asking most of them. Do you have a question, or are you just going to go sit along with? Okay. Whatever they do, you're a happy camper. Okay, so she's looking for another one. Calc, you got time for another one? Yes. Yes, anything in chapter 4 you do not do. Chapter 4 we have not done. Quiz, but it's not the one that's going to go to IB. It's just from that you turned it in, that the mistakes that you didn't catch. Yeah, everything we've been accumulating for a long time. Unless you had a terrible editing, peer edit, or you didn't turn it in on time. If you don't turn it in when it's due, it's a -5. Mark. Well, wait a minute. I've answered a lot of their questions.
That's fine. Yeah.
Sure? Okay. Page 12, number 22. So we've got page 12, number 22. 7, 11, 12, number 22. Ooh, okay. So this starts with dy over dx. What does this mean, dy over dx? It is a derivative. They're asking you for this. What does this mean? The second derivative. That should be here. All right. So when we go to do the second derivative, what's involved? Yes. So this becomes d2y over dx2. We say first times the derivative of the second plus the second times the derivative of the first. So what happens to our dx over dx? Okay. So now what do we have? We've got d2y over dx2 is equal to 2x squared y dy over dx plus 2xy. So if you got this far squared, if you got this far, you did great. If you recall, what did they have us do with this, which was on a test that you all had to do? See, this is on, so what did you have to do? Correct. Substitute what? This first derivative gets substituted for the first derivative. So this is going to simplify to 2x squared y times x squared y squared plus 2xy squared. So I don't know what this looks like. What is it going to be? 2x to the fourth, y to the third. Is this any one of their multiple choice answers? I believe it is E. Okay, methods. Number 2. We are now, so now this is methods. Seniors, this is for you. This is number 2 on 15B, I think. Okay. So on this one, we have a probability distribution. So is this one of our objectives? Probability distributions? I like probability distributions. Can't say, I can't believe, all right. So we've got this little z, and this little z is 2, 3, 5, 7, and 11. They've told us this is 1/6, and this is 1/6, and this is 1/6, and this is x, and this is y. And this is the probability that our big Z is equal to little z. So what do we know about this row always? It sums to 1. So this right here is going to give me 3/6 plus x plus y is equal to 1. Or x plus y equals a half. Does that make sense? Okay. So, now they're telling us that the expected value of x is 5 2/3. I don't like 5 2/3. Do you mind if I make that 17/3? How do we get e of x? 2 times 1/6 plus 3 times 1/6 plus 5 times 1/6 plus 7x plus 11y. So you're going to have 2/6 plus 3/6 plus 5/6 plus 7x plus 11y. By the way, this is 17/3.
So now you see how.
So we've got 5, 6, 7, 8, 9, 10 sixths
What do you do with this?
plus 7x plus 11y is equal to 17/3. Do you agree this is 5/3? So when I subtract 5/3, I'll get 12/3 or 4? Yes? Okay. So now you've got x plus y equals 1/2. Can you work with this? What do you want to solve for? So y is going to equal 1/2 minus x. So we're going to have 4 is equal to 7x plus 11 times 1/2 minus x. So you're going to have 4 is equal to 7x plus 11/2 minus 11x. If I multiply by 2, I'll have 8. equals 14x plus 11 minus 22. Then I don't have, I multiplied everybody by 2, so I don't have denominators. Okay? So we're going to subtract 11. We have negative 3. 14 from 22 is 6, 7, 8. Negative 8x, what is x? 3/8. So if x is 3/8, how do we find y? So we're going to have y equals 4/8 minus 3/8, or 1/8. Okay, Calc, next question. Page 121. Yes. Okay. So this is page 121, number 20. All right, so we're going to color code again. Okay? It says let f be a function that's differentiable. What does that mean? You can, okay, so the derivative exists everywhere and exists and it's continuous. You see, that's a disguised way of saying continuous, and that's always an important piece. On the open interval a to b, so since that's an open interval, I'm not looking at mean value theorem. F has a relative minimum. Relative minimum, what does that mean? Pardon? Okay, that involves the first derivative. What did the first derivative do? Specifically, how did it change? It went from decrease. Okay, so it went from negative to positive, meaning our function, right, f, went from decrease to increase. All right, so it's a relative minimum, f of c. I'm sorry, I lost it. Oh, cf of c. That's the ordered pair, okay? Now, they're telling us that A is less than C, which is less than B. In other words, this relative minimum is in between A and B. All right. They love this I and stuff. So let's look at this. What does this say? This says that f prime of C equals 0. What does this tell? What does this mean? F prime of C equals 0. You write this all the time on justifications. Well, f prime of C equals 0 means the derivative equals 0. That's one step in what? Critical numbers. So do you agree that that means it's a critical number? Okay. So is that true if we have a minimum? Why can't it be undefined? What tells us it can't be a sharp turn? Right, differentiable means no sharp turns, so it has to be 0. It can't be undefined. Okay, then it's saying that f double prime of C must exist. All right, if the first derivative exists, does that mean the second derivative has to exist? Is there any guarantees there? There's no guarantee. That's a maybe in the scheme of things. So a maybe is not necessarily true. So now they're saying if f double prime of C exists, okay? So now they're telling you it exists. Then f double prime of C is greater than 0. What does second derivative greater than 0 mean? Concave up. And what did they tell us this was? What's the only type of extrema on this type of graph? Look at it. A minimum. What's this called? It's on your test. Coming up. Bye. What is it? It's concavity, but this is how we tell if there's a min or max. It's another type of... It's the second derivative test for what? Extrema. So is this true? Yes. Is this true? Yes. So which one is it? 1 and 2 only. Tell me the answer was C. Okay. Okay. This is why. Gets me every year. So if f double prime of C must exist, there's no guarantee. F double exists, then f double prime of C is greater than 0. F double prime of C could equal 0. This is where the test fails, and then you go to the first derivative test and then determine what it is. You with me? Remember how on the second derivative test, the second derivative was greater than 0, the second derivative was less than 0, or the second derivative was equal to 0. This was concave up min, this was concave down max, but if you get 0, if you get 0, the test fails, which means you can't tell from the second derivative, you go back to the first derivative. So, second derivative test is no guarantee because it could be 0, meaning that it fails and the first derivative test has to tell you that. So that's why it's A only. All right, methods?
15C number 2.
Okay, so methods we're now, I don't know what section we're on. 15C, okay, number 2. So 15C, number 2, all of it, X is a binomial distribution,
Just A and C.
and I believe this is the number of trials, this would be N, and 1/3 is going to be the probability. So we want the probability that X is less than or equal to 2. So this would be 6 choose 2 because it's equal to 2. And that would be 1/3 to the second, and that would be then 2/3 to the fourth. That is the hand way, that is the non-calculator way. If we're doing a calculator, which it said we can, that's going to be binomial CDF because it's less than. And you would binomial CDF, you give the number of trials, you give the probability of 1/3, and we're taking 2 at a time. So the difference with B, now B is the probability that X is less than 2. That means the probability that X is less than or equal to 1. So when you do a CDF, you've got to go you've got to get the inequality so it includes the last one. This doesn't include 2, so it must be less than or equal to 1. PDF means at 1, equals 1. So, right, so just so that you understand that this is X equals 0 plus the probability that X equals 1 plus the probability that X equals 2. That's another way to think of this. Okay, so this is going to be 6 choose 1 now of 1/3, no, of, yes, 1/3 to the first and 2/3 to the fifth. Or binomial CDF, and we've got 6 trials, we've got 1/3, we want 1. And CDF will do everything from below it up to that point, including that point.
So C had the less than or equal to bar thing.
Right, now this did not. So C, I took it as is. This, I had to rewrite it so it had that bar.
Yeah.
Got to have that bar.
But I thought that the less than or greater than or equal to bar meant that you used the other binomial.
Did you use what? PDF?
PDF or CDF.
Okay, the inequality sign ensures CDF. Doesn't,
So no matter if it has the
correct.
equal.
PDF is equals only.
Okay.
And so that would be A. So if I want probability that X is equal to 2, then that's going to be the binomial PDF, 6 things, 1/3, 2. And that's going to do that one only. Okay, Calc, your turn again. I think Rhonda's turn. 6 on page 72. 6 on 72. Derivative, for what value? Oh yeah, we can do that. You can do A, B, and C. Did I say A, B, C? Yes, so you need to do that one. Mira?
What about this one? What about this one? That one's good, right?
112 number 2? Okay. So this is calculus. This is page 112, number 2. An equation of the line tangent. Equation of tangent line. What do you need for a tangent line? 2 things. Slope of the tangent line and point. Okay. To the graph, we have y equals cosine x plus tan 2x. And we want it at 0, 1. So what's the only missing link that we need? We've got our point. How do I get the slope of a tangent line? Okay, what's the derivative of cosine x? So it's going to be negative sine x plus, what's the derivative of tangent? Secant squared 2x times what? Times 2. So y prime is equal to, and this is non-calculator, negative sine x plus 2 secant squared 2x. Oh, so now what are we going to do? So we're going to substitute. Y prime of 0 is going to be negative sine 0 plus 2 secant of 0 quantity squared. This 2 on the outside is not squared. You with me? So what's sine 0? 0. All right. So secant. Secant is r over x. And at 0, you've got the ordered pair 1, 0. So this is going to be 1 over 1. So secant 0 is 1. So y prime of 0 is basically going to be 2 times 1 squared, or 2. So now we're going to do y minus the y is equal to 2 times the x. So if I look at my equations, they're all y equals. So it should be 2x plus 1, and that was B. Okay, methods. 15C number 3. Okay. You still looking?
15E number 1.
15E number 1. So 15E says x is binomial. We don't know our n. We know 0.6. And they're telling us that the probability that x is less than 1 is equal to 0.0256. Okay, so this probability that x is less than 1 means the probability that x equals 0, because that's the only thing less than 1, is 0.20 or 0.2, whatever this number is. So we know that in things taken 0 at a time, we take our probability, which is 0.6 to the 0, and then we're going to do 1 minus 0.6, which is 0.4, to the n minus 0, or n, and that is equal to 0.0256. In things taken 0 at a time is 1. Anything to the 0 power is 1. So this is going to be 0.4 to the n is equal to 0.0256. So to get n out of the exponent position, we're going to natural log the left. We're going to natural log the right, which gives us n natural log of 0.4 is equal to natural log of 0.0256. I don't know. What did it say? You had to. This is binomial. And it's a missing n. It was on your other tests. Okay. And remember, you have to go up to the next even one. If it doesn't say it, then it's not. So let's say this comes out to be 2.1. Then n is 3. If it's 5.6, then n is 6. Calc? Mark?
8 was 41.
41.8 we already did.
Oh, you did?
I think. Hold on. Maybe not. I might have done that in class. I definitely did number 7, yes. Yes, sir?
Do you have a list of all the people going to Cape Coral?
I do.
Can I see it?
If you give me, I did 7. If you go get my binder, big fat binder over on the short file cabinet, yes, I did.
Right. Oh, picture of that real quick.
Yeah. Position is given as x of t is equal to t cubed plus 22t minus 3 minus 6 cosine pi t. All right, they want to know for what value of t is the velocity negative. So I think I apologize because I think you need a calculator. But you would first of all do the velocity function, correct? 3t squared plus 22, and then that's going to be plus 6, because derivative of cosine is sine, right? Pi t times pi, because you do the derivative of the inside. Now that's supposed to be set it equal to 0, and there's no way you would know how to set that equal to 0. Okay? So maybe I should delete that one. Probably. So we would go to y equals, we would clear this, we would come down here, we would clear this, we would come up here, we would make sure that we're on radian, because in calculus that's the only mode we use, and then we would type in 3t squared plus 22 plus 6 sine, and that's going to be pi t, so we're going to do second. I think that's pi. T, close the parenthesis, and then that's going to be times pi. And then we're going to graph, and I'm going to zoom 6 to see if we see anything better. Huh. So, do you see this graph below the x-axis? I don't think the velocity is ever negative. Was it e? Do you see? There, we graphed it. That is the velocity function. Where is it negative? It's never negative. It's all above. Okay. Methods.
I keep getting the wrong answer.
Did you add them up and set it equal to 0 on 1? So this is page 5 distribution. This is page 551, number 1. So we're looking at the bottom row. It's 0.3 plus 1 over k plus 1 over k. Oh, that's 2 over k and 0.1. So this is 2 over k plus 0.1 plus 0.1, and that should be equal 1. So that's 0.3, 0.4, 0.5. 0.5 plus 3 over k. Does that make sense? So when I subtract 0.5, do you agree that's a half? So 3 over k equals 1/2. So I'm going to get k equals 6. What did they ask for? They said find the value of k.
But why?
Divide by 3 and then they're...
Yeah, why wouldn't you just divide by 3?
Because k's in the denominator. You divide by 3, you're going to have 1 over k equals 1 over 6. You can't pop k out of the denominator. I cross multiplied.
Well, you can flip k out of the denominator if you flip
Right.
6 out of it.
Does that give you what the questions? Do we have any algebra 2 going? How many?
That's how I...
Okay. Other questions? Yes, methods. I mean, AP's turn. 169. Okay, so I got space. Page 169, number 43. Okay. Let f be differentiable. All right, then we hit that word again. What does that mean? What does differentiable mean? Right, derivative exists and it's continuous. Okay. The table below gives values of f of x and the derivative of x. Which of the following statements are true about the function? At x equal 2, the function is increasing. Well, if we look at f of 2 is equal to 5. And we know that f prime of 2 is equal to 4. That is positive, that is greater than 0. What is the fact that the derivative at 2 is greater than 0 means happening here? It is increasing, so 1 is true. Number 2 says there's a relative minimum from -1 to 1. A relative minimum. So we've got f of 1 to be 0. We've got f of -1 to be 0. We've got f prime of 1 to be 2. We've got f prime of -1 to be -2. All right. So there is a relative minimum between -1 and 1, but not necessarily at x equals 0. Not necessarily at x equals 0. So at 0, the function is 1. So the question is, at -1, the derivative is -2. At +1, the derivative is 2. We know it's continuous. We know it's differentiable. So therefore, if your first derivative's gone from negative, decreasing, to positive, increasing, that would be our function. Is there a minimum? Yes. So this one's true also. So now there's a relative maximum in the interval. Is there anything, let's see, relative maximum? We know that f of 0, what is f? F of 0 equals 1. And that's going to be greater than f of 1, which is 0. We know that f of 0, which is 1, is greater than f of -1, which is f of -1, -2. So f of 1 is 0. F of 0 is 1. So if I were graphing this, f of 1 is 0. F of 0 is 1. F of -1 is -2. They are saying that there's a relative maximum somewhere in that interval. True or false? True. So all three of them are true. Trey? Questions? Okay, AP. Yes. $25 on page 14. 25. Oh, that's a related rate. So this is page 14, number 25. All right. The circumference of a circle. Circumference of a circle is pi d or 2 pi r, right? I don't know which one we need. And it is increasing. So the circumference, that means the derivative of circumference with respect to time. The circumference of a circle actually is increasing at a rate of 1/2 meter per minute. What is the rate of change of the area? So we're looking for rate of change of the area, which is pi r squared, when the radius is 4. Okay, so my radius is changing, my area is changing. I can't do any derivatives I can't do any substitutions right now. If I were to go to the equation I need, I get dA over dt is equal to 2 pi r dr over dt, correct? We want the rate of change of area. I know my r to be 4, but what don't I know? Dr over dt. That's dc over dt. So that means we're going to have to come back over here. The derivative of c with respect to t is going to be, the derivative of r is 1. And then that's going to be times dr over dt. Now they told us that dc over dt was 1/2. So we're going to put 1/2 right here. And that's going to equal 2 pi dr over dt. So the dr over dt, when we multiply by the reciprocal of 2 pi, is going to be 1 over 4 pi. So now I can come back over here, 2 pi times 4 times 1 over 4 pi. And look at that. That simplifies with that. So I'm going to get 2. So dA over dt is equal to 2. All right, so I'm going to call it a day because I got papers to grade. I haven't even started. I'll put this on public so hopefully everybody can access it. All right? From the left.